The instance that I am going to share with you today is another example of a statistics solving a crucial problem so effectively and beautifully. This incident happened during the Second World War. During the Second World War, a large number of people had to be recruited in the army, and there were a large number of young people who had applied for this. But there was a problem. People suffering from certain rare diseases were not to be recruited. For screening the applicants against these diseases, individual blood tests were suggested. These blood tests involved much work, time, and cost. But the tests were crucial in determining the fitness of the applicants for the army. The government was facing much problem, especially with respect to time and cost. The question was, is there any technique to reduce time and cost, ensuring fully that no person suffering from these diseases is recruited? A brilliant solution to this problem was given by a statistician. His suggested solution was like this. On going through the results of the blood tests already done, it was found that on the average, only 1 out of 20 suffered from a disease. That is, out of 20 individual tests, on the average, the report of 1 is positive. It is evident that if a number of blood samples are mixed and tested, the mixture would be positive only if 1 or more individual samples are positive. It was suggested that a lot of 20 individuals be first divided into 2 groups, each of 10 individuals. Take the mixed blood sample of all the 10 individuals of the first group in 1 test tube, and the mixed blood sample of all the 10 individuals of the second group in another test tube. Then test each of the 2 mixed samples. On the average, one mixture would be negative and the other would be positive. Now for the group for which the test is positive, to identify that which individual or individuals are positive, test each of the 10 samples separately. In this way, the total number of tests required would be 2 plus 10, that is equal to 12, where initially it was 20. So there is a reduction in the tests by 8 out of 20, that is 40%. Now a very natural question arises. Can it be further reduced or it is optimal? Yes, it can be further reduced. It may be seen that if mixtures of 5 samples are considered, the total number of tests needed on the average is 4 plus 5, that is equal to 9, which is the optimum saving of 11 tests for each batch of 20 individuals, that is 55%. A general method for the optimum solution for such situations can be found in this way. Suppose that P is the proportion of affected individuals. We have to find the optimum group size for mixing the samples. If n is such group size, then we have to find that n which maximizes the expression 1 minus p whole to the power n minus 1 by n. 1 minus p whole to the power n minus 1 by n. The best way of finding the optimum n is to tabulate the function 1 minus p to the power n minus 1 by n for different values of n, and to choose that value for which the value of this expression is maximum. This idea can be applied in other areas also, such as samples of water for different sources can be tested for contamination using this technique. It can be used in environmental pollution studies also, and many other fields like this. This is the beauty of quantitative thinking. This is the power of statistics. Thank you.